Hello class and welcome to Math Minutes video number 18. Turn to page 23 in your notebooks. We're going to start looking at how to solve one-step equations with a single variable. We're going to start learning how to solve for x. Believe it or not, you've been doing this for a long time in your math career as an early student. Do you remember seeing problems like this in worksheets in first grade, second grade? 2 plus, and there's a nice big empty box, equals 5. What goes in the box? I'm hoping you said 3. You actually just did algebra. The way algebra, though, would do this is to say 2 plus x equals 5. Now that looks like an algebra problem, right? It shouldn't be that foreign to you anymore, though, if you think that the x is simply a symbol for a number that we don't know yet. So let's turn to our notes. Solving one-step equations. A variable is a symbol for a number we don't yet know. X is the most common symbol, but any letter of the alphabet can be used. I can actually use any symbol I want. I could say 2 plus question mark equals something. I could say 2 plus peace sign equals something. It's just a symbol. We just like to choose X. To solve for X means that we're going to figure out what number X is being used to signify. For example, in the equation x plus 3 equals 4, we know that 1 plus 3 equals 4, so the value of x is 1. We know that in our heads. We can just do that simple arithmetic. But what happens when the equation is a little more complicated? Well, then we need to look at how do we solve something like this algebraically. Big word, I know, algebraically. We use algebraic steps to isolate the x or get x by itself. We've got to strip away things that are around it. This is done by performing the opposite operation to undo a number. As we practice these, this will make more sense. Simply take good notes and you'll refer to these when we're working our problems. So in the above example of x plus 3 equals 4, we want to isolate x by getting rid of the 3 that's on the same side of the equal sign. Because the equation is adding 3, it's a positive 3, adding 3, it's a positive 3, we're going to do the opposite operation, which is subtraction. If we subtract 3 from the left side of the equation, it results in x plus 0. Because if you're starting with a positive 3 and you subtract 3, it's 0. It's basically eliminating it. We then come to the golden rule of algebra. What is the golden rule, you say? Look at the box at the bottom of your worksheet. The golden rule of algebra is whatever you do to one side of the equation, you must also do to the other side. Algebra likes things to be fair and equal and balanced. We cannot do an operation on the left side and ignore the right side. Turn to the next page and let's look at this a little further. So to apply the golden rule in this example means we must also subtract 3 from the right side. So in that earlier example, we subtracted 3 to get 0. And so what that means is we kind of cancel that out. And what's left over here? What's left over here is just x. So we've isolated x. We got rid of everything that was around it. But our golden rule says if I subtract 3 from this side, I also have to subtract 3 from the other side. So 4 minus 3 is 1, therefore x equals 1. Now we knew that in our heads, but that's how you do it algebraically. Solving for x is an essential skill for being successful in algebra. We will be spending a lot of time learning, reviewing, and practicing this skill. Note: I don't want to assume that you understand every little thing. So this might seem very simple to you, but again, let's just have complete notes that you can refer to if you get stuck on your homework. Addition and subtraction are opposites. So addition will undo subtraction. And subtraction will undo addition. That's why in this earlier example, if I can erase my marks, when we had a positive 3, we do the opposite operation. Opposite of addition is subtraction, and they undo each other, meaning the result will always be 0. Same is true with multiplication and division. They are opposites. So multiplication will undo division, and division will undo multiplication. We're ready to practice. Turn to your next page. Our first problem, number 1, x plus 7 equals 12. We know this in our heads, I'm hoping. We know that x is going to equal 5, but let's do our algebraic steps and see if we're right. X plus 7 equals 12. Well, my goal is to get x isolated all by itself. So I need to get rid of this 7. I'm going to do the opposite operation. What is the opposite of adding 7? Subtracting 7. I'm going to subtract 7, golden rule, from both sides of the equation. What does that leave me with? It leaves me with x, because 7 minus 7 is 0. X equals what? 12 minus 7, x equals 5. Number 2. Our goal? Let's get x by itself. Let's isolate it. What's stuck with it? What's on the left side of the equation is 20. Is 20 positive or negative? If there's no sign in front of it, it's understood that it's always going to be positive. So if we think this is a positive 20, how are we going to undo it? What's the opposite of adding? Subtraction. So we're going to minus 20. We're going to subtract 20. Are we done? Nope. Golden rule of algebra. If I do it to one side, I have to do it to the other side. So if I'm subtracting 20 from this side, I must subtract 20 from that side. What am I left with? Well, these cancel each other out, so the only thing left on this side of the equation is x. What does it equal? 27 minus 20, 7. So in this case, x equals 7. Let's take a look at this problem. We might see something a little bit different here. Oh, we have a few more numbers, but you know what? That's okay. Let's just simplify. Can I add x plus 4? I can't. But I can combine negative 10 and a 17 because they're like terms. So I'm going to first simplify this side. What does that give me? What is negative 10 plus 17? You can refer back to your notes if this is confusing. Which direction on the number line are we going to do? Are we going to go? We are adding a positive number, so we're moving to the right. Well, if we're starting at negative 10 in the whole and I move 17 to the right, I end up with a positive 7. So negative 10 plus 17 is 7. So I've combined that. Now my problem is x plus 4 equals 7. Well, now I get to isolate my x. I'm going to do the opposite of an adding 4. So I'm going to subtract 4. Golden rule, subtract 4 on that side of the equation as well. What do I end up with? X equals 7 minus 4 is 3. Let's look at our next one. Let's do some combining. I can combine over here. 14 plus 2 is 16. So now my problem is x minus 9 equals 16. I want to get rid of anything that's doing anything to my x here. I'm going to isolate it. Opposite of subtraction, addition, I'm going to add 9. Golden rule, I'm going to add 9 to that side as well. That gives me x equals 16 plus 9 is 25. Let's take a look at this symbol. We have an x that's in parentheses. This is showing that it's being multiplied. 3 times x, whatever x is, equals 21. Well, what is the opposite of multiplication? Division. Now, how do I divide? What am I dividing here? I want to separate that 3 and the x because right now they're being multiplied together. I want to separate them. I want to undo. So I'm going to divide by 3. So if I divide by 3, I'm going to use a fraction bar because remember fraction is another way to write a division problem. 3 divided by 3, 3 over 3, basically it's 1. So that just becomes 1. A golden rule, if I'm going to divide this side by 3, I have to divide this side by 3. So when this becomes 1x, 1 times anything, it just means it's x. Once you've canceled that, you're just left with x by itself. What is 21 divided by 3? And that would be 7, because 3 times 7 equals 21. Let's take a look at the next one. Now, we might be ready and anxious to be like, oh, I know what to do. I'm going to divide this by 2. Well, we're not going to do that quite yet. Let's combine what we can on this side of the equation. What is 50 minus 10? That is 40. So now we end up with 2x equals 40. Well, what am I going to do to unstick? These are being multiplied. I'm going to divide. I'm going to divide by 2. Those cancel. I'm left with x all by itself. Golden rule means I have to divide this by 2 also. Therefore, we end up with x equaling 40 divided by 2 is 20. Number 7. 42 equals 6x. Now here's something interesting. All of these sample problems that we've done before, the x has been on the left side of the equation. In an equals problem, in an equation, it doesn't matter which side is which. I can say 2 equals 2, or 2 equals 1 plus 1, or 1 plus 1 equals 2. It doesn't matter. They can be on either side. So when we're solving these equations, don't think that the x has to be on the left. We can end up with it on the right, which is what's going to happen in problem number 7 here. So what are we going to do first? There's nothing to combine over here, but we need to unstick. That 6 and that x are being multiplied. They're stuck together. We got to unstick those, guys. Divide by 6. They cancel. Golden rule, I have to divide this side by 6 also. 42 divided by 6 is 7. 7 equals x. You can see different problems. We ended up with the same answer, but they mean the same thing. It does not matter what side of the equation your variable or x lands on in the end. Our last practice problem together, let's do some combining first. We have negative 18 and we're minusing a number, 6. We're going to go left in the number line, so we're going more in the whole. 18 in the whole and 6 more in the whole give me negative 24 equals x plus 3. My next step, I'm adding a 3 here. I want to isolate x. I want to get that all by itself. So I'm going to do the opposite of adding 3, and I'm going to subtract 3. Now, I'm still in the whole negative 24, and I'm going more in the whole 3. So I end up with negative 27 equals x. Please remember to complete your notebook along with each video. Bring it to class completed for full credit. I'll see you in class.